Hi, today is our first lesson on logarithms, specifically converting exponential equations to logarithmic equations and vice versa. We're applying what we know about the basic properties of logs. We're working on pages 19 and 20 in our math packet, and tonight's homework is page 21 and 22. First thing I'd like to say about converting either between exponential and log or between log and exponential is that you always have to remember the phrase Roman numeral 9. And what that tells us is, first of all, our exponential equation would have to be in this format with b raised to the x power equals y with b raised to the x on the left. The Roman numeral 9 comes from moving the b down and switching places between the x and the y. So if I'm converting between exponential and log, this becomes log base b of y equals x. So now I have successfully converted my exponential equation into a log format. Same thing can be done when I have log base b of x equals y. I can bring the b down and switch places between the x and the y. B raised to the y power equals x. So putting that into practice, we can convert our logarithmic equations, convert our exponential equations into log. Roman numeral 9, log base 2 of 8 equals x. Roman numeral 9, log base y of 4 equals negative 1. Log base 10 of 1,000 equals 3. Now remember, when we're doing anything log base 10, if you remember in our calculator and you look at it, we have a log button right here on our calculator. And anytime we have log base 10, that means it's our log button. So we could really just write it as log of 1,000 equals 3. Converting between log and exponential. Remember, first thing we do is we rewrite the equation with log base 3 of 5 equals y, the log base 3 of 5 on the left. Roman numeral 9, 3 raised to the y power equals 5. Log base d of 7 equals negative 2. Roman numeral 9, d raised to the negative 2 equals 7. Log base b of d equals a. Roman numeral 9, b raised to the a power equals d. Solving for x. So we are rearranging, most likely converting to exponential when we start with logs to solve our log equations. So Roman numeral 9, 2 raised to the negative 3 equals x. You should be able to either put that in your calculator or do it in your head. 2 to the negative 3 is the same as 1 over 2 to the positive 3 power. Therefore, the answer is x equals 1 over 8. Roman numeral 9, 27 raised to what power equals 3. For this one, you're going to have to do a little bit more manipulation to solve for x, at least at first, until we get to solving logs tomorrow. 27 can be written as 3 raised to the 3 power, because 3 times 3 times 3 is 27, and then that it's to the power of x still equals 3. Nothing changed on the right. I can write this as 3 raised to the 3x power. Remember, because power to a power says multiply my exponents equals 3. 3 is raised to what power if I see no exponent is 1. And remember, like bases can have their exponents set equal to each other. So 3x equals 1. Therefore, x equals 1/3 is the answer to 3b. Last one, Roman numeral 9. X raised to the 1/2 power equals 4. So x to the 1/2 is rational. You can convert it to exponential. So the square root of what equals 4? I can square both sides to get rid of the radical sign because this is the square root and squares undo square roots. So x equals 16. Answer to 3C. Moving on. Moved on too much there. Number 4. Express as a sum of logarithms. Try to remember back to pre-calc when you started to learn logarithm rules. If I'm expressing as a sum, that's the same thing as expanding our logarithm. And if I have a multiplication between what's called the argument, if this is the base, this is the argument, and if I have it equal to anything, that's usually called the exponent. When I'm multiplying those arguments, I can expand by saying log base, the same thing, so log base 2 of 4 plus log base 2 of 16. Now, when we start having instructions like simplify, then we must look at the log and see if we can solve it. So when I see log base 2 of 4, if I did it very quickly as a Roman numeral 9, it's going to be 2 raised to a power equals 4. So we already know that in that case, this x is going to be 2. So the answer to log base 2 of 4 is 2. Same thing over here. 2 raised to the what power equals 16? The answer to that is 2 raised to the power of 4 equals 16. So 2 plus 4, the answer to 4A is 6. B just requires us to expand because there's nothing to solve for if there's no numbers. So expanding means changing multiplication of arguments into addition. Log base 9 of m plus log base, I'm sorry if I said 9, I meant d. Log base d of m plus log base d of n. C looks like we're going to also have to solve. So if I'm writing it out, let me change colors so we can see it more clearly. Log base 5 of 25 plus log base 5 of 5. So taking each one separately, 5 raised to what power equals 25? That would be 2 because 5 times 5 is 25. Log base 5 of 5 means 5 raised to what power equals 5? 5 raised to the first power equals 5. So the answer to 4C is 3. Moving on, express as a difference. So anytime I have division between my logs, I'm going to expand as a subtraction. So just using letters, log base A of m minus log base A of n. B, log base 2 of 8 minus log base 2 of 4. This is, if I use my Roman numeral 9, 2 raised to the what power equals 8. The answer to this would be 3. Minus, I'm just carrying this down, Roman numeral 9 again, 2 raised to the what power equals 4. 2 raised to the second power equals 4. So 3 minus 2 equals 1. The answer to 5B. Express as a single logarithm. So now we're not expanding, we're contracting. So we're changing from addition to multiplication. So log base 5 is just written one time, and in parentheses, it's now 9 times 3. Otherwise, well, you can expand that out. I think it's 7, carry the 2, 57. So log base 5 of 57. Or you can leave it in this format also if it says express as a single logarithm. Same thing again here. Here's addition. These are the same log bases. So write it one time, log base 3 of 7 times 5. Answer as a single logarithm, log base 5 of 35. Last one is just kind of a fun one. Remember, every time I have addition, I change it to multiplication. So log base A written one time of C times A times B times I times N. Log base A of cabin, log cabin, ha ha ha. On to page 20, if we haven't started that already, express as a product. So this rule tells us that I'm always going to take the exponent and move it to the front as a coefficient. So if I'm expressing it as a product, it becomes -5 log base B of 9. For the second one, first I'm going to change it to rational log base A of 5 to the 1/4, because if I have the 4th root of 5, this is radical, this is rational, and the exponent moves to the front, 1/4 log base A of 5. Express in terms of logarithms of x, y, and z. Currently, everything looks like it's multiplied. So if I'm expressing in terms of logarithms with a bunch of arguments that are multiplied, I am expanding into addition. So log base A of 5 plus log base A of x plus log base A of y to the 4th. Oops, that's supposed to be a plus sign, sorry. Plus log base A of z raised, or z cubed, or z raised to the 3rd power. And then since I have exponents that need to be moved to the front as coefficients, I have one more step for my final answer to 8A. Log base A of 5 plus log base A of x plus 4 times log base A of y. Oh, this is supposed to be A. Come on, pen. Plus 3 times log base A of z. For B, 8B, we're going to have to first get rid of our radical and convert to rational. So I'll start all the way over here because it looks like we'll need room. Log base A of the whole thing raised to the 1/4 power. This is square root. So when I do square root, radical to rational, I change it to the 1/4 power. So now I'm going to distribute, because that's what we do with power to a power. Every exponent, including the ones you don't see, get raised to that 1/2 power. Log base A of z to the 3/2 over x to the 3, nope, sorry, x to the 1/2 and then y to the 1/2. I'm going to